Okay, so if we first discuss about the basic definition of potential difference, then you will easily differentiate between two concepts of EMF and potential difference, right? So let's check what will be the difference. So first, if we write potential difference, and we already know that EMF is only connected with the cell, battery, or the source of potential, right? There will be no interaction with the circuit or the load
Yes.
that is connected with the battery. So now let's see what will be the difference in potential difference. So let's suppose if there is a circuit and that same source is connected and there will be a load over here. Let's suppose a lamp is connected. So this is the electrical symbol of lamp, a round circle with a cross in the center, and plus minus is the symbol for a battery or a voltage source. This will be positive, this will be negative. So let's suppose if the voltage of the battery is equals to 3 volt, right? So
Yes.
when charges start flowing from positive end, right? So charge will flow from the positive side, from this end through the lamp, and after passing through the lamp, it will again towards the negative side, right? So in EMF, we discussed that energy is going to convert from one form to another, right? So energy is converted, that is the part of EMF. Now that electrical energy is going to be travel into whole circuit, right? Or you can say travel through the components which are connected in the circuit, right?
Yes.
Okay. So now that energy is going to be consumed
Mm.
by the components of the circuit, right?
Yes.
So what are those components? Let's suppose in this specific circuit there is only one component, that is lamp, and the main purpose of lamp is to light up the lamp or consume the energy from the battery, right? So let's suppose if 3 volt is supplying from the battery, and after passing through the lamp, what do you think, that potential or the voltage will decrease or remains constant?
What again?
If 3 volt or a voltage of 3 volt is supplying from a battery and lamp consume some amount of energy
Yes.
or voltage, so what will be the voltage at this point? Let's suppose at this point specific B, is it equal to 3
Uh,
volt or less than 3 volt or greater than 3 volt or something else?
it will be less than 3
Less
volts.
than 3 volt, right? Because some energy is already consumed by the lamp, right? So let's
Yes.
suppose before passing through the lamp, at this point voltage is equals to 3, and after passing through the lamp, let's suppose this is only assumption, or we can say that we only assume values for our understanding, we are not calculating the exact value. So let's suppose after passing through it, voltage will be equal to 1.5, right?
Yes.
Now you can easily and clearly see the difference in the voltage there, right? Because in before it passing from the lamp, before passing through the lamp, the voltage is 3, and after passing through the lamp, the voltage is now 1.5 volt, right? So what will be the difference
Yes.
in the voltage? We need to subtract these values.
It becomes less.
Yes,
It becomes less.
it becomes less. So this 1.5 is the actual potential difference. So that's why we used to say that this is the potential difference. That's why we use word potential difference. That it shows you the difference between initial potential and final potential, right?
Hmm.
Okay,
Um,
clear? Any confusion?
no.
Okay. So this is the basic difference between EMF and potential difference. Now you got clear concept that why EMF is different, or why the concept of EMF is different from potential difference, right? Because
Yes.
EMF is only connected with the source. There is no involvement of other component in the circuit, and potential difference is purely connected with the whole circuit, right? Let's suppose if 3, 4, 5,
Yes.
10 components are connected in the circuit. So we first note down the initial voltage, then we note down the final voltage. That we will give, or we can calculate what will be the difference in the voltage we get, right? So that difference gives you the value of that 1.5 volt energy is consumed by lamp. So this voltage is consumed by the lamp, and the remaining voltage will travel through the negative terminal, right?
Yes.
So we can say that potential difference is the difference of voltage, difference of voltage between two terminals or 2 points, right? So basically,
Yes.
potential difference gives you the difference of voltage between any 2 points. This is very clear and very easy concept to write and to understand, right? Any confusion?
No.
Okay, and further we can say that this voltage, or we can say the potential difference, is the voltage which is connected with or linked with is linked with with the components, with the components circuit, right?
Yes.
It gives you relation between the components and the potential that is supplied by the battery or the source, right? So now we have enough knowledge about potential difference and EMF, right? So, and we also know about the AC, DC, conventional, non-conventional current. So now we have enough concepts related to current, electricity, and voltage also. So now we are able to make their relation and to study different effects in circuits, right? So now if we consider another new concept, let's suppose if a body or a car is moving on a straight road, right? And it is moving with a variable or a constant speed of any value. Let's suppose car is moving with 50 kilometers per hour. The speed of the car is 50 kilometers per hour. So do you think will be there any resistive force in the path or in the direction of car?
Which force?
Any type of resistive force?
Resistive?
So yes, in electric circuit, there will be also some resistive component or resistive force or concept of resistance there. So now we discuss about first that, then we combine all these quantities into a single relation, right? So if we
Yes.
discuss about resistors, or if we discuss about the concept of resistance, so basically, resistance is, if we define resistance, though there are two ways to define resistor. One is the actual definition, right? And second wordings, or you can say that the second statement is basically the conceptual definition, right? So if we first define resistance, so resistance basically the ratio between It is the ratio between voltage and electric current, right?
Yes.
So resistance is, in simple word, it is the ratio between voltage and electric current. And if we write this relation in the form of equation, so we can easily write is R is equals to V over I, right? So this is the relation of
Yes.
resistance, right? And in conceptual, and if we want to try to explain this concept in the conceptual way, so the conceptual explanation of this concept is like this, that resistance is the hindrance, it is the hindrance in what, in the path of or in the flow of electric current, right?
Yes.
So this is the conceptual explanation and this one is the actual definition, right? Because that definition gives you the clear electrical quantities, voltage and current. And in second statement you can easily observe that that is the conceptual explanation, right? Because there is no word or no quantity is related in this statement which is written with the green. So this is the conceptual explanation and the previous one is the definition. So hindrance in the path of electric current, so that will give you the value of resistance, right?
So the resistance is equal to voltage divided by electric current.
Yes. Or you can also write as V is equals to IR. If we rearrange this equation, we can write this equation as V is equals to IR, right?
Yes.
Okay. Now there in this equation, you can see that the whole concept we studied from the previous class and this class, the whole quantities are now combined in a single equation. V is equals to IR, right? So that's
Yes.
good and very simple equation in through which we can easily calculate electric current, voltage, resistance in any circuit. Because the equation is very simple, there is no complicated equation or no complicated process there to calculate voltage or electric current. So this is very simple, right? But before using this
Yes.
equation, we need to know about the limitations of this equation, right? So there must be some limitations or there may be some constant values or some precautions before applying this equation. So first now discuss about that constant factors or that precautions which we need to know about or know about this equation before applying to any other circuit, right? So for
Yes.
that purpose, we already have a proved law which is known as Ohm's law. So if we discuss about Ohm's law, so Ohm's law is basically related to the voltage and electric current of the circuit. That if you know about that, what will be the value of electric current if some value of voltage is applying to the circuit, right? Or if you want to calculate the voltage from the of any circuit, if the value of electric current is given there, so this formula or this law will help you to apply that equation, and that equation V is equals to IR is the application or the derived equation from the Ohm's law. So Ohm's law states that voltage in a conductor or in a circuit is directly proportional to what? Is directly proportional to the electric current, right?
Yes.
Directly proportional to the current, but there may be some conditions, some limitation to or to use this equation, and that limitations are if the physical condition, if the physical condition and the temperature of a conductor remains constant, right? We will discuss about
Yes.
these physical condition and temperatures in detail because that topic is also a part of your syllabus, right? So don't worry about that. What is physical condition and how we come to know that physical condition is constant or changing. We also discuss about the temperature, right? So if the physical condition and the temperature of the conductor remains constant, of the conductor remains constant, so this is the complete explanation of this law, and this is complete law. Not only voltage is directly proportional to electric current, we need to know about the limitations of Ohm's law. We can only apply it on a conductor or a type of conductor in which resistance remains constant, physical condition remains constant, right? And you already know about the equation that V is equals to IR. Voltage is directly proportional to current if resistance remains constant. So resistance must remain constant if you want to apply Ohm's law. Otherwise, this equation is not applicable in any circuit where resistance is variable, right? So always remember, if someone asks
Yes.
you to use Ohm's law in any circuit where resistance is not constant, so always remember that Ohm's law is only applicable on the resistor or the circuit where resistance is constant and the physical condition is constant, right?
So what again? Ohm's law is always
It is
what
only
again?
applicable on a type of circuit, right, where resistance and physical condition is constant, right?
Ah, okay.
Let's suppose if there is a wire and current is passing through it, and you light up a lighter over there or a burner over there, so you know that that wire or that conductor will melt after some time, right? So this law will no more
Yes.
applicable, right? So these type of factors we need to discuss about detail in factors affecting resistance. First, we discuss about the graph of Ohm's law, right? If we
Yes.
graphically
How do you apply Ohm's law?
in questions,
How do you
yes,
okay.
in questions,
How
values
how
are
do you
given.
apply, how do you apply Ohm's law?
Let's suppose if there is a circuit, right? There is a battery, and let's suppose
Yes.
there are three lamps, right? And the capacity of three lamps are different from each other, right? Some is small, someone is bigger, some is of average value. So let's suppose there are different capacity of lamp and different watt and voltage current consumption of the lamp. So three are connected, and if you know about their resistance, if you know about the voltage, so let's suppose if they ask you to calculate the electric current, so you can use this equation because resistance is there, voltage is there, only current is missing. So we can use this equation, right? We will solve questions. Okay, after discussing this topic, we will solve question, then it will become easy for you to identify that how we are going to solve the questions related to Ohm's law, right?
Yes. So you mean the Ohm's law is explaining the formula
Yes.
V is equal to IR.
That formula is basically first approved or derived by Ohm's law, but there will be a condition, right? In resistor, we also write that it is the ratio V over I, right? So that is something
Yes.
different. But when Ohm's law approved this law or drive this law, so it says that the resistance and physical condition must remain constant. Otherwise, this law is not applicable. Let's see how it works for us. Let's suppose if we want to draw a graph over here. So this is y-axis, this is x-axis, right? And let's suppose voltage is on y-axis, x-axis, and current is on y-axis, right? Because voltage is directly proportional to current, so current is depending on voltage, because when voltage starts supplying charges from the battery or the source, so then there will be a value of electric current. So we know that whenever both quantities or two quantities are directly proportional to each other, so the graph will be a straight line, right? Let's suppose if we start from the
Yes.
zero, graph will be a straight line. There will be no deflection, no curve, just a straight line, right? So
Yes.
this shows you, let's suppose if we take some values over here, let's suppose this is 2 volt, this is 4 volt, this is 6 volt, and this is 8 volt. Since graph is directly proportional, so we know that resistance is constant, right? That's why it is possible that graph will be a straight line and the value of current will be 1 ampere, 2 ampere, 3 ampere, and 4 ampere, right? So let's suppose if we
Yes.
want to calculate resistance, so by applying this Ohm's law on this graph, let's suppose if we take the value of 6, let's suppose if they ask you graphically to calculate the value of R over this point. So what will be the value of R? You can easily use the Ohm's law. We can simply substitute the value in the law, and V over I is equals to R. R is equals to voltage, that is equals to 6. I is equals to 3. So the value of resistance is equals to 2 ohms, right?
Yes.
And a very interesting thing, that let's suppose if you apply same law and same condition on 4 volt, right? So again you will get the same value, 2 ohms, right?
Yes. So it's actually when the electric current and the voltage, they both are directly proportional.
Yes,
So
resistance will be
if
constant.
the electric current and voltage are directly proportional, the R should be
Yes,
constant.
R must be constant there, because if both are directly, so resistance will be constant, right?
Yes.
So this is the graphical representation of Ohm's law, and you can also calculate value, or you can extract data from the graph of Ohm's law, right? That will also help you to calculate the values. Okay,
Yes.
but don't forget the limitations and conditions of Ohm law, that are very important. Now this is very short part, not much they ask about it, because the main thing which is already given by Ohm's law, that is the formula V is equals to IR. So V is equals to IR is the basic equation with that which we are going to use in our many questions, right? Very simple equation, not very complicated, easy to apply on any circuit, right? Now let's
Yes.
suppose what happens when resistance is constant, right? Because resistance will not remain constant every time. Let's suppose in any circuit, if resistance will be variable, so how we come to know that on which factor resistance depends? So we first need to know about the factor affecting resistance, right?
Yes. It's temperature.
Yes. What if resistance is variable? So one thing we know about that is temperature, and there are some other factors. Let's discuss about those factors. So now we discuss about the factors that affect the resistance. So we are going to discuss about the factors. So when we discuss about the factors, so the first factor we discuss about, that is of length, right? So the
The
first,
length of the area.
yes, the length of the wire or the length of the conductor. And the first question, let me ask you that in the power bank, right? When we use power bank to charge our mobile phone or tablet, so 99% we observe that the charging cable that comes with the power bank is very small, right?
Yes.
And what is the reason of that?
Um, because
Because there
I
is a
have no
battery in
idea.
power bank, right? Because there is a battery in power bank, and the current that is
Mhm.
going to be supplied by battery is a DC current, right?
Yes.
And due to DC current, we need to consume as much energy as we can from power bank, right? Because if we take long wires, so charge will take more time to travel. So it means current will be very low and resistance will be high, right? Because charge travel
Ye-
from one point to another. Let's suppose if you want to travel from one point to another, so the shortest path is a straight line, right? And the other alternate
Yes.
route you can choose, but that will be lengthy than that straight line, right? So that
Yes.
random or alternate path basically gives you the hindrance or the resistance in your path, right? That will consume more time to travel from one point to another. That can easily be traveled in a straight line or in the very short time, right? So same concept goes for
Yes.
the length in electric current. So if we increase the length, so resistance will also increase, right?
Yes.
So we can say that resistance is directly proportional to length. Resistance is directly proportional to length. Resistance is directly proportional to length. To the length of a wire or a length of a conductor, anything which we are going to use in our circuit. And for that, if we write equation, so equation will be like this. R is directly proportional to length, right? Increasing
Yes.
the length will increase the resistance. Decreasing the length will decrease the resistance, right? Okay, now let's talk about the second factor. So the second factor is of cross-sectional area. So cross-sectional area of a wire or a conductor. Now we are going to discuss about that factor and let's see what is actual cross-sectional area is. So let's suppose if there is a conductor and you need to first see the front face of the wire, right? Let's suppose if you are using a pencil, so from the front, you can also calculate the area because length is there, height is there. So two quantities are enough to calculate the area, right? But we are not talking about that area. We are talking about this specific area. This is known as cross-sectional area. The front face of the wire, that is known as the cross-sectional area, the diameter of the wire in simple words, right? So we are
You
discussing
mean the
about,
front?
yes,
You mean the front? How is the diameter?
yes, the circular face of the wire, we are talking about that part, right?
Okay.
So if we take example of a pencil and a marker, so you know that the diameter of the marker or the backside of the marker is greater than of pencil, right? Because the
Yes.
cross-sectional area of pencil is very short as compared to the cross-sectional area of that marker, right?
Yes.
This is another factor. And if we take a common example, let's suppose in our normal classrooms of a school, the doors are of normal size, right? And the
Yes.
main gate of the school or any building is greater than the area of or greater in the area as compared to the other doors in the building, right? So if
Yes.
children want to pass through both gates, so children will take less time to pass from the main gate of the school, right? Because main gate have
Y-
greater area, so many children can easily pass. And classroom has less area, so one or two children can easily pass from that gate at a one time, right? So this is the same concept for this wire when electrons are passing. So they are overlapping, they are pushing one another. So the greater the area, the less will be resistance. The shorter the cross-sectional area, the greater will be resistance, right? Because if the area is very short,
Yes.
electron will more overlap, more push each other. So due to that factor, resistance will increase, right?
Yes.
And when resistance will increase, okay, let me discuss after this one.
When the resistance increase, the electrons flow will be less. So the less electric
Yes,
current will flow
yes,
in the minimum time.
yes, that will affect the flow of current exactly. So increasing the area, or you can also write resistance is inversely proportional to area, right? Let's write in that well term.
Yes.
That is more. So resistance is inversely proportional. Resistance is,
To the area of,
yes, it is inversely proportional to the cross-sectional area of a conductor or a wire. In short, I am writing cross-sectional area, right? You need to write in full form. I
yes,
am writing in short. So it is directly inversely proportional to cross-sectional area. So the relation will be like R is inversely A, right? Now, if we combine
yes,
these two equations, so final equation will be like something this, right? And if we replace this proportionality sign with a constant, so there must be some constant value.
yes,
Now let's talk about that constant value. So the third important factor, is that resistivity. Let's talk about what resistivity is. So resistivity, let's suppose if there is a copper wire, there is a silver wire, there is a aluminium wire or a conductor. So in three metals, the properties of each metal is different from the other one, right? Copper is a good conductor as compared to the silver, right?
yes,
So
yes.
which conductor will give high resistance, copper or silver?
A copper, no,
Good,
no, silver,
yes.
silver.
Good conductor have less resistance and a good resistors have less conductance, right? So that's why
Yes,
we use good conductor in our circuit because that gives us low resistance. So it means that there is an internal resistance in a conductor or a wire, right? That is a built-in
yeah,
property of a conductor, right? Because conductor also has some free electrons. So when other charges starts flowing through that conductor, so they both overlap each other, right? So
yes.
that overlapping wire will also produce resistance, internal resistance, you can say that. So resistivity is the internal property of a conductor or a resistor, right?
It is an internal property, like what do you mean?
Internal property means because each and every conductor or a wire has free electrons and atoms in it, right?
Yes,
So when other charges are going to transfer through that conductor, so you imagine that the quantity of particles will increase. So there will be more
yes.
overlapping. So it is very natural that resistance will automatically increase if there is no resistance or special resistance connected in the circuit, right?
So if there are many particles, the resistance increases.
Yes. So if you are using bad conductor, so bad conductor will give you more resistance, right? Because they don't allow other charges to flow easily from their path, right? So it is the ability, we can say, ability of a conductor to produce resistance, right? It is the built-in property, we can say in simple words in our language, that is the built-in or natural property of any conductor or a wire, right? So ability of a
Yes,
conductor to produce resistance, and this resistance is not forced resistance, it is the natural resistance, right?
yes.
So resistivity is another factor, and the symbol for resistivity is equal to the sign of density, rho. Rho is the symbol. So this equation will be like this. R is equals to rho L over A. This is the final equation of factor affecting resistance, right?
And the rho is density, yeah.
That is the same symbol we use for density, but that is not density, that is resistivity, right? The
Okay.
symbols are same, but meaning are different because that symbol is used in journal physics. Now we are using that symbol in electrical physics, right? So that is
Yes, okay.
the symbol and the concept, right? Because we have many quantities in science and in every subject. So that's why we again and again use same symbol for different purpose, right?